Good morning, everybody. I hope you are doing well. We are going to start at chapter 13 on chemical equilibrium. I think you have probably heard me say that term equilibrium a few times in chapter 12. And so equilibrium is that the concept that the concentration, it also could be pressure related also, so it should be concentration and pressure, of all the reactants and products remain constant over time. Now, this is what we are trying to get to. And in our equilibrium expressions, in chapter 12, we were not concerned about our products at all. We weren't concerned about them building up. In equilibrium, we will be. So you can see that I have this forward and backwards arrow right here. Another way that you might see me write it is like this. And so what we're trying to say is that our forward reaction rate equals the reverse reaction rate. So in your book, you might see them going like this. Our forward reaction rate is equal to our reverse reaction rate. And at equilibrium, I want you guys to think about that it is very frantic what is going on inside a system when it reaches equilibrium. A lot of times people will think, oh, it's just settling down and nothing is continuing to react. And that is the furthest from the truth. The other thing we need to think about is that not all reactions are going to be able to go forward and reverse. So we know, like, burning a piece of paper is a combustion reaction. We can't get that to go in the backwards direction. We're not going to get paper back again. So not all reactions are reversible. So if we look at this first diagram here, you will recognize some of the things that we learned in chapter 12, that we have rate, we have a constant again times the concentration of N2O4. Without even looking at the equation above, you probably could recognize that this would be my reactants and this is going to be my products, because this is going to decrease over time as we learned in the last chapter. Now we have equilibrium that's going to be achieved. Again, that's going to be the letter K. The nice thing about K this time is it doesn't have any units like we struggled with a little bit in the last chapter. So once things get to that point, how is that equilibrium achieved? So the position of equilibrium is determined by the initial concentration of the reactants most of the time. I think you guys can envision that we may start studying something where the reaction has already proceeded, and so then some of the products can affect that equilibrium, but for the most part, we're going to be starting at the beginning. We also need to take in consideration the energy of the reactants and the products. The energy, the enthalpy that's there. So we've talked about delta H way back in chapter 6, so that's been a while ago. And then again, we're not leaving that activation energy. We still got to be imagining, if these are my reactants and these are my products, that this energy that I have to get over to have my reaction even take place. So we're still talking about orientation and collisions. And then the degree of organization of substances. Do we have any intermolecular forces in there? Do we have large molecules, small molecules? Do we have a solid with a liquid or a solid with a gas? Like all those different things about the organization of the substances that we're using. And keep in mind that nature still wants everything to be at the lowest energy that it can, because that requires, it's the easiest for it to attain and keep it constant. So this first chart is the same thing that I just showed you. The only thing that I want you guys to pay attention to is, I should have put these side by side, but this rate in both of these, this concentration is the same. We don't want you to think that that concentration has to always be the same when you reach equilibrium. You can see down below that my concentrations are still becoming constant, but they're at different levels. So I could look here and say, well, this is at 1.5 molarity, and maybe this one's at 3 molarity. It doesn't matter. They don't have to be the same exact number as the chart up above. They just have to remain constant at some point. So this is just a really quick little podcast to get us started by looking at these graphs and just thinking about equilibrium. And if we look down below, we can see that we ran these 4 experiments, and this is when equilibrium was achieved. Focus in on this, that we have seen that this is our reactants and these are our products. And when we look at all the numbers, nothing is the same until we get down here. But even so, our equilibrium constant is a constant, okay? So our K is not changing. Now I can see that the numbers are slightly changing there, but for practical purposes, remember that this is still experimental data, so there is going to be some fluctuations there, but I think you can agree by looking at those numbers that we have achieved an equilibrium constant. Okay, so the next few podcasts are going to get some numbers in there and some math for those of you that love to do some algebra. I hope you're having a great day.